Welcome to Exponentials and Logarithms, Lesson 5, the Natural Logarithm. It's part 5 of our 6-part series, and today we're going to look at the natural logarithm. We've already seen, looking at inverse in previous examples, we've already seen that the inverse of y equals 10 to the x is y equals log base 10 of x. So therefore, the question is, what is the inverse of y equals e to the x? And hopefully you can see here that it's going to be y equals log base e of x. And we call this the natural logarithm. And because it's got a special name, we actually didn't say log e to the x, we call it ln x. And we call that word ln x. And there are two things you need to know from this as well. If I were to ln e to the x, I'll get x, quite a useful property to know when solving and rearranging formulae. How does that work? Well, we know that ln can be written as log base e. So here we have log base e of e to the x. The x can come down to be in front of the log, and therefore we get log e of e, which we know as 1. So therefore I can do that, and also e to the ln x equals x. So the exponential of the ln of x equals x. Let's look at the 3 examples they have in the book. Firstly, the first one. Make x the subject of the formula a ln 2x equals b. Always in this situation, what I like to do is clean up the ln, the values here around ln x. So you can do that simply by dividing both sides by a. Let's look at the solutions they have here. Yes, what they've done is divide both sides by a first, and then they get ln 2x equals b over a. And we've got to use these two. Okay. In this particular case, I want to get rid of the ln. I'm just making it the subject. So I want to get rid of the ln. So I'm going to do e to the ln x, and that makes that side become 2x. But whatever I do to one side, I must do the same to the other. So therefore, this becomes e to the power of b over a. And now I get rid of the 2 by dividing both sides by 2. Second example. A radioactive substance of initial mass 200 grams is decaying, so that after t days, the amount remaining is given by this formula here. The half-life of a substance is the time it takes to decay to half its initial mass. And the question here is find the half-life of this substance. So we know that actually the initial mass was 200, so half of that is going to be 100. And we need to now find a value of t. In order to do that, I need to get rid of everything here. So I'm going to clean it up first. I can get rid of the 200 by dividing both sides by 200. So I get a half. Now I need to get rid of the e. In order to do that, I need to ln both sides. So I ln both sides. I get ln a half equals this set of values here. I can work that out on my calculator. So I'm now going to divide both sides by negative or minus 0.0015. And I get t equals, and I get this fraction here, put it into my calculator, and I find that its half-life happens after 462 days. Copy neatly this out in your books, it will help you. Let's go for the third example. Find the coordinates of the points on the curve y equals e to the 3x, where the gradient is 10. The word gradient should help you remember of the gradient finder. So if you think about the gradient finder, you're thinking of dy dx. And here they tell you that the gradient equals 10. So if I know the gradient equals 10, let's differentiate y equals e to the 3x. And remember, when you differentiate e to the kx, what happens is the k becomes a coefficient. So in this case, y equals e to the 3x becomes dy dx equals 3e to the 3x. And if dy dx equals 3e to the 3x, if it equals that and it also equals this, then that equals this. Again, let's clean this up. Let's divide both sides by 3. And then I want to get rid of the exponential. So in order to get rid of the exponential, I need to then ln both sides. I need to ln this side. By doing that, this simply becomes 3x. And on the right-hand side, it becomes ln bracket 10 over 3. I can then divide both sides by 3, so that I end up with x equals 0.401. Don't forget it says the coordinates, always read the question, be careful with that. So I need to now substitute x into this equation here, So y equals e to the 3x. If I did that, I come out my y value, and so my coordinates are 0.401 and 3.33. Just a cautionary tale, don't put that value in, put the whole value in that you have in here and multiply by 3. You don't want to make a carry through silly error.